Okay, everyone. Today we're going to take a look at percent yield, which is what we use to measure the fact that we can't get exactly what we want to have each time that we have it. All right, so in the world there are sources of error. Okay, when we perform experiments in the laboratory, we never get all of the product we theoretically could get. Reactions in the laboratory are not ideal. For example, consider the reaction of sodium metal and chlorine gas to produce salt. If we react 23 grams of sodium metal with plenty of chlorine gas, calculations tell us that we should get about 58.5 grams of sodium chloride. However, if you tried this in the lab and then took the mass of your final product, you would usually get somewhat less than 58.5 grams. The more careful you are, the closer you can get to the mark of 58.5 grams, but you'll never be able to make 58.5 grams of sodium chloride. What are some practical things, some sources of error that can happen in the lab and in a reaction that would cause us to get less than 100% of the product we're trying to produce? Okay, there's a whole bunch of things that can take place. There can be difficulty of collecting the product. Okay, you might have it stick to the glass or adhere to something else in there, some way that it makes it hard to get it out of there. You could have, there could be side reactions, right? Other things that happen that make you get less than that. We saw that with our magnesium oxide lab. One of the side reactions made magnesium hydroxide. And so if you collected just the magnesium oxide and left out the magnesium hydroxide, you'd have a problem and you wouldn't get all of the reaction you were supposed to. And you probably saw that with some large errors in there. Gases like to escape. Right? And there's a whole bunch of other things that you could have. You could continue this list for quite a while, talking about all the different ways in which chemical reactions are hard to quantify on the product end because other things are happening at the same time. It might get too hot and you decompose something. It might not get hot enough for something else. So there's all kinds of reasons that you might have, but here's some of them. Right? The information section above made it sound like we could always get less than 58.5 grams of salt. However, it's possible that after the reaction we could take the mass of the product and find that it's greater than this. According to our calculations, this should be impossible. But what sources of error might cause this? Right? Again, one of the most common ones here are side reactions or contamination. Okay, in the magnesium oxide lab you saw that there were side reactions like the magnesium hydroxide we talked about up here. Magnesium hydroxide weighs more than magnesium oxide. And so if you had that in there, you'd have it. The other thing is contamination, right? To get rid of the magnesium hydroxide, we added water. If we failed to drive off all the water afterwards, we've got water as a contamination that added more mass than it should have had. Okay? So, if I have 40.5 grams of sodium and it reacts with plenty of chlorine gas, how many grams of sodium chloride should be produced? This is asking you to find what's called your theoretical yield, which is basically a fancy of saying, what's the math say? Right? What does the math tell you you should get? So let's find out. 40.5 grams of sodium. Right? If I look on my periodic table here, sodium is 22.99 grams. 22.99 grams of sodium per 1 mole of sodium. I want to know how much sodium chloride. There's 2 to 2. So 2 moles sodium chloride for every 2 moles of sodium used. And I want to know the mass of it. So 1 mole of NaCl, got to add that up. Okay, sodium is 22.99 plus chlorine 35.45. Okay, so 58.44 grams. All right, so let's do the math. 40.5 times 1 divided by 22.99 times 2 divided by 2 times 58.44 divided by 1, and I get 102.9 grams NaCl. Okay? Now, percent yield is a measure of how much of a product you would actually obtain in a reaction compared to the amount that you could have contained according to calculations, right? There's a handy formula for calculating this. It's right here. Percent yield is simply the actual yield over the theoretical yield times 100, right? Theoretical yield is the amount of a product we should be able to make. You calculated the theoretical yield of sodium chloride in question 3. Hopefully your answer was about 103. Ours was. Okay, now let's say that you actually attempted this experiment in the lab with 40.5 grams of sodium, and when you were finished, you collected 84 grams of sodium chloride. This amount is your actual yield, the amount of product you actually collected in lab. Using this formula, we can calculate that. 84 grams, our actual yield, divided by 103, our theoretical yield, times 100, gives us 81.6%. Okay, so let's do a couple of these. Consider the combustion of 215 grams of butane with plenty of oxygen. If you're able to collect 295.3 grams of water in this laboratory, what was percent yield? Hint, first calculate your theoretical yield using the balanced equation and mole ratios. All right, so let's figure that out. We have C4H10 plus oxygen gives us CO2 and H2O. All right, I'm going to have to double this off the bat because this will give me 5 oxygens if I put this over here, so I'm going to need an even number to get an even number here, so I'm doubling it. So I'm going to need 4 times 2 is 8 CO2s. All right, this is going to give me 20, which will allow me to put a 10 here, right? 10 single oxygens will give me 5 O2 molecules, plus the 8 O2 molecules that go into here. 5 and 8 is 13. Okay, so there's my equation. 215 grams of C4H10 times 1 mole C4H10. And how much does that weigh? Let's take a look at our periodic table, right? And add this up. Carbon, 12.01 times 4 plus 1.008 times, how many did we say we had here? 10 equals 58.12 grams times my mole ratio. Let's see, we are looking for water, right? So I have 10 water, 10 moles of water for every 2 moles C4H10, right? Let's see, I got to add up water here. 1.008 times 2 plus 16, right? 1.008 and 16 equals 18.016 grams of water per mole of water. Okay, plug it in my calculator. 215 times 1 divided by 58.12 times 10 divided by 2 times 18.016 divided by 1, and I get 333 grams of water. This is a calculated result. This is my theoretical yield. Okay, theoretical yield. I was only able to collect, if you were able to collect this much. This is my actual yield, right? So that is my actual yield. In these problems, you'll always have to be given it. If you were doing a lab, that'd be the amount that you were able to collect in lab. You might have to do some subtraction to get it out of the beaker, but that's where you would get it from lab. In a problem, they always have to give you this. Okay, so let's do this. 215 grams actual yield divided by 333 grams theoretical yield times 100. 215 divided by 333 times 100, 64.6%. Okay, consider the double replacement reaction of excess sodium chloride with silver nitrate. Right? Sodium chloride is NaCl plus silver nitrate, AgNO3. It's a double replacement reaction, right? The silver and the chlorine, right, is a +1 and a -1. This will be the solid that we form. Plus nitrate and sodium, those are +1 and -1. So NaNO3, and that's balanced as written. Excuse me. So I'm going to react 203.9 grams AgNO3, right, times 1 mole. AgNO3, how much does silver nitrate weigh? Silver's in here, 107.9 plus a nitrogen, 14.01 plus 3 oxygens, 16 times 3, right? 169.91 grams. Silver chloride is what I'm looking for. I have 1 mole of silver chloride for every 1 mole of silver nitrate. This is necessary to get from moles of silver nitrate to moles of silver chloride, which is what I'm looking for. 1 mole of AgCl weighs, what does that weigh? Again, 0.9 plus chlorine 35.45. Right. This is 143.35 grams. Right, plug it in my calculator. 203.9 times 1 divided by 169.91 times 1 divided by 1 times 143.35 divided by 1. 172 grams of AgCl. Right? If you were able to produce 150.4, there we go. That's my actual yield. This is my theoretical yield because I calculated it. 150.4 grams over 172 grams times 100. 150.4 divided by 172 times 100. 87.4% yield. Okay. Now, if I make 46.8 grams of calcium carbonate by reacting this much calcium nitrate with plenty of sodium carbonate, what's my percent yield? Right, I'm going to take these over to the back where I have more room. 46.8 grams. 46.8 grams of calcium carbonate. 87.5 grams calcium nitrate. 87.5 grams calcium nitrate with plenty of sodium carbonate, right? All right, so these two things are reacting. This is what I start with. says I collect or produce, right? What did I say? I make, right? So this is my collected amount. This is how much I made. I started with this and I added that. So I need a balanced equation. CaNO3 2 plus Na, oops, there's a 2 there, 2 CO3, sodium is a +1, carbonate's a -2, so I gotta make that right. I'm gonna make calcium carbonate, CaCO3, and I'm gonna make sodium nitrate. Sodium is a +1, nitrate's a -1, so I only need one of each. These two will show up in a different way, right? I'm gonna make sodium nitrate, but when I balance the equation, I find I have 2 nitrates and 2 sodiums. That 2 goes here because the compound is NaNO3, right? So now I have a balanced equation. Okay, I want to know what the percent yield is, so I've got to start with this, 87.5 grams of calcium nitrate. Okay, so let's add this up. Calcium 40.08 plus, I'm going to put it in parentheses because I have 2 of these, 14.01 plus 16 times 3 to get the nitrate, times 2, all right, 164.1 grams, 164.1 grams per 1 mole, CaNO3 2, all right, multiply that. My mole ratio is 1 to 1. 1 mole of CaCO3 for every 1 mole of CaNO3 2, right? Because I have 1 of these to 1 of those, right? I need calcium carbonate. 1 mole of calcium carbonate weighs what it weighs, right? Calcium 40.08 plus a carbon 12.01 plus 3 oxygens. Oops. Okay, calcium, carbon, 3 oxygens. All right. 100.09 grams equals, all right, so let's see what that equals. All right, 87.5 times 1 divided by 164.1 times 1 divided by 1 times 100.09 divided by 1 equals 53.4 grams of CaCO3. Right? This is my theoretical yield because I calculated it. My actual, remember, is up here. 46.8 grams divided by 53.4 grams times 100 equals 46.8 divided by 53.4 times 100 is 87.6% yield. And that's how you do percent yield problems.